Once you finish installing DQMH, this VI is going to show up. This allows you to validate any existing projects you have. You can also launch this tool by going to Tools, Delacore, DQMH, Module, Validate DQMH Module. Another feature of 5.0 is that once we select a project, in this case, a project done using DQMH 4.2, now you have the option of either validating a single DQMH module on your project, in this case, a singleton or a clonable module, or now you can validate all DQMH modules in a specific project. The first one that we get here is that the close module was upgraded in DQMH 5.0 to use a more robust synchronization mechanism to close event references when the first clone instance is shutting down. The previous implementation used a polling mechanism that could result in race conditions in very rare corner cases. So once we figure out that that was an issue, we fixed it for DQMH 5.0. So we go to the close module BI and look at the block diagram. As soon as we press the fix issue button, you're going to see some DQMH scripting magic happening there. So everything that you're seeing there, the code moving around, that was done via the scripting tools. Now I'm just going to clean up the block diagram a little bit. This is not the scripting tools. And normally this is not needed, but I am doing it so it's easier for me to show you what changed and why. So let's let the cleaning up and moving all the wires to a better area finish so I can show you what changed. I am splitting the screen. On the top, we have the cleanup code with DQMH 5.0 that we have already validated and upgraded. And on the bottom of the screen, I have the previous code with DQMH 4.2. So first thing is we're going to see that the module bit stop is moved farther into the code. For 4.2, what we used to do is we would do that exactly at the beginning. We realized that we really need to send that broadcast once we have removed the module from the clone. Otherwise, you could see modules listed in the clone registry even if they were no longer running. So this allows to make sure that the broadcast says the module is stopped once it has already been removed from the clone registry. The other thing we did is we added this last notification firing. The next one is request and wait for reply timeout error VI not found. There is no request and wait for reply timeout error VI in this module. This custom VI was added in DQMH 5.0 to improve error generation when timeouts occur with request and wait for reply VIs. So when we fix this, what's going to happen is we have already all these error constants. And as soon as I press the fix issue, we get that new one there that's called request and wait for reply timeout -- error. We're going to do the same thing for the singleton. In the singleton, we have less errors there, but same thing. As soon as I press the fix issue, we get request and wait for reply timeout -- error. In combination with that previous test, we have this one where request and wait for reply with no timeout error. This module contains the following request and wait for reply event VI that do not generate an error on timeout, that do something else and wait for reply VI. So what we're going to do is we're going to go to the project and open the request for do something else and wait for reply. On 4.2 and earlier, we just following the same idea of the notifier that just returns a Boolean that says whether it timed out, but it was not translated into an error. So one of the feature requests from you was to make sure that we would return an error when there was a time. Right. So now as soon as I click the fix issue button, again, we're going to see some DQMH magic happening here. And now I'm doing some cleanup so I could show you the difference. And what we did is now when there is a timeout, we get that constant that was created on the previous test. And that's the VI that we generate to add an error to our merge errors. Same thing for the singleton. As soon as I press the fix issue, we're going to see the DQMH scripting magic, and all we did is, and we didn't do some cleanup in here, but just showing the same thing where if there is a timeout, we are going to be taking that timeout error constant and putting it in the merge errors. This one is a quick one. There's no release queue VI in the top level error case. And all you see is we create the queue here, but then in the error case, we don't destroy it. So all we do when we press the fix issue in this case is just adding the destruction of the queue. And we're going to do the same thing for the singleton. We create the queue here. We were not destroying it. As soon as I press the fix issue, the destruction appears. This is the most involved change that we did. The start module VI for this module uses the run VI method to launch the module, and we change it to use instead the start asynchronous. So what's happening here is this is what it used to look like. We had our launching of the module. We would change and set values using control value set method as well. And like I said, we were using the run VI. The clone ID was set via the clone name. So when we press the fix issue, we're going to see here is a lot of changes. And you're watching again some DQMH magic here happening. And just so it is easier for me to explain what changed, I'm going to do some cleanup. And I'm speeding up the video, so obviously I don't code this fast. And so we're cleaning it up. And let me show you. Once it's done, we're going to see the main differences. All right, so if we look at this one from the original 4.2 and we look at the left of the 5.0, they're the same. That part didn't change. What we changed is on the 4.2, we were using the open VI reference and setting it for reentrant clonable. And now we have this action engine where we're doing for simultaneous reentrant calls. And we create the reference once and then we store it in this action engine. So what's going to happen now is we create it there and we store it once. And the other change was that the module ID. So when you compare how we did it in 4.2 versus 5.0 now, we are automatically generating the number and it's now going to be an integer that starts at 1. The next big change is we have this type def. This type def has the connector of the main VI. So if I go and open, and let's say I want to add, keeping track of the name of the clone instance, and I'm going to connect that to the connector pane. Now my connector pane has changed. I have to now drag my main VI into the connector pane on that type def. That changes it. And now I can actually connect my name directly into the start asynchronous call. And I can connect it to the start module. The way we used to do it in 4.2 is if you wanted to do something similar, you would go to your main VI, you would put your name on the front panel. You didn't need to connect it to the connector pane because the way you would access it was with the control value set. So you would copy the module admin code we had in there, you would put the name of the control you were using, and then wiring that, and that's how you would do it in 4.2. We're finishing there the connection. Okay, so that was, again, that's how we used to do it in 4.2. I wanted to show you the same thing, how it's now done on 5.0. It's very similar for the singleton. We're also using the start asynchronous call. It's going to be a little bit less complicated because we don't have to be managing the multiple instances. So in this case, the start module used to look very similar. We had our own VI server, etc. And as soon as I press the fix issue, we see the DQMH scripting magic. I am doing some cleanup so I can show you. So like I said, it's pretty more straightforward than the clonable one. We still have to do the thing of changing the reference of the VI if we decide to connect something else. So what I'm going to do is do the same exercise that we did for the clonable. I'm going to put a string control on the front panel called name, and I'm going to connect it to the connector pane on the singleton. And then once that's connected into the connector pane, we are going to drag it the main VI into the VI reference. This is not a type def, okay? So in this case, we're just going to put the name, we're going to connect it, and we are all ready to go. If I wanted to do the same thing on the singleton, again, I didn't need to connect it when I was on 4.2. I only needed to do the name of the connector and use the control value set to set it up. So we're doing the same thing here on 4.2, showing you how it was done before, so you can compare the new way of doing it with the old way of doing it. This is a convenience thing. When we use the API tester as a sniffer, you don't want for it to stop the module. So what we have done is we wrap the stop module with a case structure. So if the module was running when the tester started, then it's not stopped, and it is a stop if it wasn't. So what we do now here, you can see as soon as I press the fix issue, the stop module is going to get wrapped into a case structure, and all we do is check if the VI was already running. So what that means is, if, for example, I run my application and I start a new instance of the Carnival module, the second instance of the Carnival module, they are already running because my application is running. If I now open the API tester and I refresh, I see my two active modules. I can still show them, I can do all my debugging, but when I stop the API tester, the modules still run. It is until I stop the application that they stop running. If I run them by themselves, so nothing running, I run the API tester and I add a new first, and then I add a second. But this time, they were not running when the tester started. So as soon as we close the tester, all the modules stop. Same thing for the singleton. If the API tester has at the end the stop module not encased in a case structure, we are going to encase it in a case structure, and then go to the project, go to main, run my application, and I can run the singleton. And if I go to the API tester and run the tester, I'm able to sniff it, I can do things to it, etc. And when I stop the API tester, the module doesn't stop. And I go back to the application, I can still manipulate it from the application, and it's until I stop the application that the singleton module stops. The last test is the wait on stop synchronization. This functionality in the Carnival modules has been improved in DQMH 5.0 to only wait until the current instance of the Carnival module stops running. This is an improvement over the previous behavior, which would only wait for all instances of the module to stop. So what we're going to see is the way it used to be is as soon as I click the fix issue, it's going to make that case structure a little bit bigger. And let me do some cleanup again. And you can see that the true case still looks exactly the same. And it is on the false case that we are signed up to the module did stop, and we verified if the module that we're waiting to stop is the one that actually stops. So we're done. We're going to rescan all the modules, and of course, still everything passes. There's no more remaining tests to do. Thank you.